So thanks everybody. My name is Chris Anderson. I'm a co-founder of Couchbase and a developer on our one of our core products. So I work on the mobile side of things. I'm here to convince you that mobile is really huge and not to be ignored even when we're talking about databases. So how huge is mobile? Well, maybe today it's not as huge as cloud, even though it is still pretty huge. We're talking $1.1 trillion in revenue flowing through the entire mobile ecosystem. This is operators and everybody. But it's getting much bigger, and this is even just 3 years from now, it's projected to be 15 billion connected devices. So what does that have to do with Couchbase? Well, first I'll talk a little bit about the technology, then about how people are using it in the mobile world. Quickly, what makes Couch? It has a very reliable storage engine. This means that if the battery pops out on your phone, you put it back in, you're not going to be waiting for a fix-up phase while there's a consistency check or something. Every time data is written to disk, it's safely retired to disk and available for reads in a consistent fashion. You know what JSON is. Replication now is a really killer feature of Couch that I haven't seen duplicated anywhere else in the open source world, and maybe the closest thing to it these days is Lotus Notes, and that's getting long in the tooth. So with the Couch synchronization and replication, what we're able to do is take two databases and make them the same, and do it in an efficient way, and do it at near real time. And I'll talk more about this in a minute. MapReduce is how you query it. MapReduce is really ideal for if your data looks all kinds of every which way different. So there's other NoSQL databases that can store stuff that looks all different. But when you need to query heterogeneous data, you need to drill into what you've stored and say, oh, if it's one of these, do this. Use this regex on it if it's one of those. Pull out the data you need. So for instance, you're storing test reports in your database, and they're all different because they're coming from different versions of your software. You have a regex that knows how to read it out of this test report, how many passes and fails, and a different set of software for digging it out of a different storage format. MapReduce allows you to essentially normalize at indexing time. We also have a geographic index, which is powered by an R tree, which is designed for bulk insertion. So I've seen the entire edge set for the US Census working on one little small, one rack unit server that was donated to a nonprofit. And it's all based on HTTP. What this means is that if you can scale HTTP, you can scale Couchbase. So where are we today? We have Couchbase Mobile running on iOS, and we have it running on Android. And that's just the tip of the iceberg. Probably a lot of folks here know that iOS and Android, these are the big platforms. But I really see them as the beginning of what's happening with mobile. So what we want is to be on more than just smartphones, right? It's anything that's out there in the real world that needs to record data, that needs to link that data up with nearby objects and help make data collection at the edge and not lose anything. So when you are certain kinds of hardware, you need to work offline, right? If you're a cell tower and you're out in the middle of nowhere and you get disconnected, that's the point when your embedded database needs to work. You need to be able to figure out, how do I recover from this error condition? Also, you want a database that is active. So if your car moving this way, another car is coming this way, maybe you can exchange some information about traffic conditions up ahead on the road. We like to call this ground computing. Ground computing is kind of by contrast to cloud computing. Cloud computing is great, the cloud is great, it's done a lot for us, yay Web 2.0. But there's a lot of places the cloud can't reach, and that's where we're there to fill in. You want your data to be with you when you're disconnected. And so this is, ground computing, it's not my phrase, but I really like it. So that's an intro. Now you know a little bit why we're here, what we're doing. What can you do with it? So I mentioned earlier, real-time sync is core to what Couch is capable of. It's got this is as technical as I'm going to get. It's got this HTTP API where you run a little HTTP command, and now these two are the same. You can run it in continuous mode, you can run it, and then it'll stop when it's done. You've got these kinds of options. It's efficient, it's not going to transfer data that the target already knows about. And it's designed to use low amounts of battery and also treat the HTTP transport mechanism well. So you've got low latency, you can use it to power things like chat rooms, etc. You don't have to replicate everything at once. You can replicate just the stuff that belongs to user X. So that gives you a tremendous amount of flexibility. I'm going to skip through all this flexible stuff you can do with it, but doesn't that look cool? So, you can do social applications, collaboration. You can do really interesting security model stuff. And these are some users in San Diego, Assay Depot. They're in the pharmaceutical industry, and what they do is they broker information exchange among pharmaceutical companies. So if you're one big pharma and there's another one, maybe you might want to have some jobs that any contractor out there in the world can fill. Anyone with a robot who can do stuff with 10,000 test tubes, they can fill this job. We might have other jobs that are kind of top secret. These pharmas, they tag the jobs with who's allowed to see them, drop them into Assay Depot, which then replicates using a filter so that what you see is what you get as far as the auditing layer. So if you're Novartis, you're connecting, you only have access to this bucket of data that you're allowed to have access to. And it's very easy after the fact to prove who is allowed to see what when. Even more interesting, I think, is this network of health clinics in rural Zambia. They use Couch to bridge the lack of internet. So they're using cell phone modems and computers stationed in these rural clinics. All the computers are accessing a local database instance, so everything is zero latency no matter how connected you are or how disconnected you are. And then when the wind is blowing the right way and the cell phone network comes up, it synchronizes with the head office and saves a bunch of doctors a bunch of time and bumpy truck rides. In Portland, there's a bunch of data activists that are taking zip files of geographic points that are and all over the country now that are in this like hard to read shapefile format, sticking them in GeoCouch, and now an activist can keep this couch up to date without worrying about it being high availability. You can make a high availability replica of it and provide that as a data source for your iPhone application. Of course, the applications go much deeper than this. There's some interesting stuff in defense and real estate and any kind of extractive industry. So the last thing you want to know about Couch is that to use it right, you've got to relax. If you think too hard up front about stuff, you're going to get yourself in trouble. But if you just put the data you've got in there, figure out how to query it, that's what works for people. This is the Couch gang sign. It kind of looks like the rock and roll horns, but also it kind of looks like a couch. Thanks.
All right, thank you very much.